Ladies and gentlemen, this is section 7.1 on the multiplication and division of monomials. We have 4 warm-up questions here today. It's Friday, so I know your brains aren't quite all working. And the first question says, use associative property to solve the multiplication of this monomial by this monomial. Okay, and we know they're monomials because monomials or terms, by definition, are the product of numbers and variables. This is negative 2 times x times y multiplied by negative 3 times x times y. So essentially what we need to do here is we need to think about the order in which we multiply terms. Since this is a straight multiplication, it's this times this times this times this times this times this times this. We can rearrange it in any way we want without affecting its product. So what you want to kind of articulate, even though when you actually solve it, you're not going to, you want to rearrange the product of terms to show that you understand multiplying it that way will help you simplify this into one monomial. If you multiply the coefficients first, you're going to get a positive 6. If you multiply 2x's or 3x's together, you're going to get x cubed in a simplified form. And y multiplied by itself twice will be y squared. And therefore, this monomial multiplied by this monomial will simplify to give you that monomial. The second question says model 3x times negative 2x. So essentially what we use for modeling is what's called an area model. This can be considered the length, this can be considered the width, and this could be considered the area, right? This is what we're dealing with. So when we have those 3 parts, we're going to consider this to be our length, this to be our width. Length times width would equal the area, or 3x, which I'll use these very poorly drawn x tiles, multiplied by these 2 poorly drawn negative x tiles. The area will be the center part and the answer to the product. So if I trace out the area and then compartmentalize where the things would be, we can see that those are going to be x squared tiles. Now the question will be, are they positive, constant, or negative x squared tiles? Right, because this is a positive and this is a negative. And from our understanding of sign rules, this will all be negative x squared, so we can put that in there. Therefore, the answer to this, which is the area, will be negative 6x squared. The last 2 questions are the division of monomials by monomials. So the first thing says use cross reduction to solve this monomial divided by 2y. And essentially what our brains have to think about is, if I thought about the coefficients as being like a fraction, multiplied by, and I'm going to take my x term because it's by itself. There's no x terms down here. So I'm just going to put a 1 because there's no x terms in the denominator. Multiplied by y over y. If I broke down the question into this, and let's just say, just for half a second, if I covered it up. Can I cover it up here? Yes, I can. If I covered it up and I gave you these 3 fractions and I said multiply them together, right? If you multiply them together, you would multiply your numerators. You'd go negative 10 times x times y, and you would get, I can kind of hide this now, can't I? You would get this. If you multiply this by this by this, that's what you would get, correct? And if you multiply this by this by this, that's what you would get. So when we think of it this way, what it allows us to do is divide or cross-reduce the coefficients. Because if I had negative 10 over 2, I wouldn't use that. I'd reduce that down to negative 5 over 1. So over here, what I would really do is I just go negative 5 over 1 like this. X over 1 doesn't change. It just becomes x. It doesn't have any effect. X doesn't, it stays itself. But y over y would reduce down to 1 over 1. And since we're dealing with products, a 1 doesn't affect the product. So essentially, they cancel each other out. And what I'm left with is just negative 5x, negative 5 times x times nothing else, over 1, which means my solution is just the number negative 5. Does that make sense to people? We're really just cross-reducing the parts that can be cross-reduced. Yep. The x stayed, oh, sorry, the x is there. My bad. Thank you, Madeline. X is still there. You're right. My mistake was actually crossing it out. I shouldn't have crossed it out up here. I should have kept it as is. It doesn't reduce. It just stays as x. Okay. And your last question says write the equation. Here again, it's almost like we have a rectangle again. This is our length, this is our width. And our area inside is, our area is negative 6x squared. So if I made a simpler one, I just put 2 area equals 8. What's this side here? If I asked you, what is that missing side? You'd all know it's 4, correct? And the way you would do that, you'd say, well, if I took the area, 8, and divided it by the side I know, it will tell me the side I don't know, which is 4. That's a useful way to solve a lot of different math questions. Think of an easier one. So using that exact same logic, taking the area, which is negative 6x squared, dividing it by the side I know, which is 2x, will equal the side I don't know. And what I can do here, I think these, hang on a second, grab that, throw it away. Let's just delete it. Boom. I can actually fill in the algebra tiles that are missing, which are x tiles. I just have to ask myself, are those going to be positive x tiles or negative x tiles? They're going to be negative, correct? Because just like Bronson said before, a positive times a negative is a negative. That's the only way those can be negative. My answer, therefore, is negative 3x. Okay? Any questions? No, Shep? Yes, Shep? No, Shep?